Question 1. Mrs. Chia bought an iron and a kettle for $279.30. The kettle cost $39.70 less than the iron. How much did the iron cost? So as you can see, when it says the kettle costs $39.70 less than the iron, that means the iron is $39.70 more than the kettle. We know the total is $279.30. So that means the kettle is essentially 279.30 minus 39.70, and then we divide it by 2. This will cost $119.80. So for the iron, it is $119.80 plus 39.70, and this will be equal to $159.50. There you go. Question 2. According to this watch, John finished working on his project at 13:20. His watch was 15 minutes slow. What was the actual time John finished working on his project? So if it's 15 minutes slow, so for example, if it's 10 o'clock in the watch, that means it is 10:15 in actual time. Therefore, so the actual time, if it's 13:20 and 15 minutes slow, that means 13:20 plus 15 minutes will be equal to 13:35. Question 2, part B. According to his watch, John finished working on his project 13:20. His watch was 15 minutes slower. John spent 2 hours 45 minutes working on his project. According to the actual time, what time did he start working on his project? So we know that the finished actual time is 13:35. So that means his actual starting time is basically 13:35 minus 2 hours and 45 minutes. So we can break this down. So it's 13:35 minus 35 minutes minus 2 hours 10 minutes. So this leaves us is 1300 minus 2 hours and 10 minutes. Okay, and we minus 2 hours will be 1100 minus 10 minutes. Okay, that will leave us to 1050 hours. There you go. Question 4, part A. The figure below shows a triangle with its 3 sides. True or false or not possible to tell. The length of side C is longer than the length of side B. In this case, we just need to prove whether side C is longer than side B. So let X be 1. So that means side C would then be equal to 4 times 1 plus 2, which is 6. Then side B would then be equal to 5 times 1 minus 2, which is 3. So that now we can just swap this into a different number. So if you were to use 2, 4 times 2 is equal to plus 2. This is equal to 10. 5 times 2 minus 2 is equal to 8. Still okay. Let's move to 3. So 4 times 3 plus 2 is 14. 5 times 3 minus 2 is 13. Okay, side C is still bit longer. How about side 4? X before. So 4 times 4 plus 2 is 18. 5 times 4 minus 2 is also 18. So you could see that side C and side B is actually the same. If you were to do 5, so 4 times 5 plus 2 is 22. 5 times 5 minus 2, this will be 23. So the thing is that if X is 4, C and B is the same. If X is 5, B is more than C. If X is 1, C is more than B. So in this case, it really can't know. So it's not possible to tell. Question 4, part B. The perimeter of the triangle is 12x plus 4. So total perimeter can be equal to 3x plus 5x minus 2 plus 4x plus 2. So we were to bring all the x's together. So 3 plus 5 plus 4x will be 12x. Minus 2 plus 2 will be 0. So that's the total parameter. So the total parameter is not 12x plus 4. So in this case, it is false. So part C, the triangle is an equilateral triangle. So the property of equilateral triangle is that all sides are the same. So remember that there was one point where if X is 4, side C and side B is 18. But side A is 3 times 4, which is 12. Therefore, if one side is not the same, then it's not possible and it's false. Question 5. A total of 24 lamps are set up at an equal distance along 3 sides, AB, BC, and CD of a rectangular hard court. The figure below shows part of the setup. The length of the hard chord is 195 meters. What is the breadth of the chord? So we know that there is a total of 24 lambs. And one side of the lamb, AB over here, we can calculate. So AB is equal to 1, get a bit bigger. So we have 1, 2, 3, 4, 5, and 6. So there are 6 lambs. And DC will also have 6 lambs. That means the remaining is equal to 24 minus 6 minus 6, and this will be 12. The remaining itself, right, has no corner dots. It's in B and C. So that means B, C is, so 12 is not the number of lambs of B and C. We need to add the two corner dots. So therefore, BC is equal to 12 plus 2, which is 14. Okay, so if there 14 lambs, so 2 lambs has one gap, cause it's essentially 2 minus 1, which is equal to 1 gap. So 14 lambs is equal to 14 minus 1. This will give us 13 gaps. So that means 13 gaps is equal to 195 meters. One gap equal to 195 divided by 3. This will give us 65 meters. Sorry, 13, not 3. So it's 15 meters. So the breadth is essentially BC. So the breadth, the number of lambs in BC is equal to 6. Sorry, AB, not BC. AB, 6. So 6 lambs equal to 6 minus 1 equal to 5 gap. So we know one gap is 15 meters. So 5 gaps equal to 5 times 15, which is equal to 75 meters. There you go. So the answer is 75 meters. Question 6a. Question 6, part A. John folded a triangular piece of paper along the lines of AB and AC, and DB is equal to DA. Find the angle X. So this is angle X over here. Let me highlight in red. So angle X, if you were to look at the original before folding, where do you think angle X is? If you say angle X is this, then you're right. So this is angle X. So to find angle X, we need to have 180 because it's part of the triangle over here, which is A, C, and the corner here. So AC something. So angle X minus, let's put Z over here. So minus 45 minus CAZ, angle CAZ, which I want to put this as green. So angle CAZ, if you were to look at the folded angle over here, where do you think it is? So if I were to draw out the folded angle-ish that we are looking for, then that means this green angle is actually 26 degrees. So that means angle CAZ equal to 26 degrees. So therefore, angle X is 180 minus 45 minus 26, and this is 109 degrees. There you go. So part B, you want to find angle Y, as what you see over here. Angle Y in the not folded angle, where is it? Before folding, I mean not folded. Angle Y is essentially over here. So you can put angle Y. So now the thing is, how do we get angle Y? Basically, angle Y is equal to 180 minus 45 minus angle BDA. So BDA is basically this green angle over here. So how do we get angle BDA? If we were to look back over here, angle BDA is over here. So the thing is that from the question, it says DB, which is this part, is also the same as DA. Sorry, DB and DA looks like this. So which means that this angle, this triangle over here is an isosceles triangle. Triangle DDA, right? Since DB is equal to DA, triangle DBA is an isosceles triangle. So that means we technically can get this angle, right? So this orange angle over here, it's basically, what do you think this orange angle is? If you think it is 54 degrees, then you're right. So that means this 54 and this is also 54. So since we know angle BDA is equal to 180 minus angle BAD, and then we divide all of this by 2. So do we know angle BAD? Yes, we do, which is 54 degrees. So 54, sorry, this is not divided by 2. So it's just 2 times of BAD. So this will then be equal to 72 degrees. So now we know this corner angle. We can find angle Y. Earlier, we know what's the equation for angle Y, which is 180 minus 45 minus angle BAD, which is 72. And this will be equal to 63 degrees. Okay, there you go. So that's the answer, 63 degrees. Question 7, part A. Black and white squares are used to form figures that follow a pattern. The first 3 figures are shown below. What is the difference in the number of black and white squares used for figure 4? If we look closely, so figure 1 difference, it's basically 5 minus 4, which is 1. Figure 2 difference would then be 8 minus 6, this will be 2. Figure 3 difference will be 11 minus 8, which is 3. So I think you know what's figure 4 difference are, because figure 1 difference is 1, figure 2 difference is 2, figure 3 difference is 3, figure 4 difference will just be equal to 4. There you go. So that's the answer, 4. Question 7, part B. Another figure in the pattern had 20 more black-white squares. What is the total number of black and white squares in the figure? So the thing is that another figure in the pattern had 20 more black and white squares, which means that the difference go to 20, which means if difference is 20, that means it's figure 20. So now we know that it is figure 20. The next thing is, what is the total number of black and white squares? So if you see the total squares, that is from figure 1, 2, and 3, you'll see that it is increasing by, what do you think? How many? So from 9 to 14, it is plus 5. Is it the same with 14 to 19? Yep, it's the same. It's also plus 5. So there is this equation where we can get the total numbers if the adding number over here is the same. So the equation, we call this the adding number pattern, would be equal to starting number plus figure number minus 1, so it's set brackets, and then times adding number. So this is a very, very useful equation if you want to find out how many or what's the number according to the figure number. So the starting number over here is 9. So for figure 20, starting number here is 9. And then plus figure number is 20 minus 1. And then times adding number, which is 5. So the adding number is the plus 5. Figure number is the figure number we're looking for. And the starting number. Okay, let's see how much this is. And the answer is 104. There you go. So that's the answer. Question 8, part A. Water leaked from 2 different taps at a constant rate in 2 identical buckets. Tap A took 50 minutes to completely fill the bucket, while tap B took 80 minutes to completely fill the bucket. The tap with the faster rate leaked 30 milliliters more water per minute than the slower one. Which tap A or B leaked water at a faster rate? So tap A took 50 minutes to fill the bucket, and then tap B took 80 minutes fill the bucket. Let's say the buckets are 400 milliliters. So that means tap A rate would then be 400 milliliters divided by 50, and this will be 8 milliliters per minute. Then for tap B, 400 milliliters divided by 80, this will be 5 milliliters per minute. So essentially, tap A actually has higher. So that means tap A leaked water at a faster rate. So for part B, what was the capacity of each bucket in liters? So for this, to calculate the capacity, right, according to rate. So for example, we have a rate of 10 milliliters per minute. And another example is that we have 10 minutes. So example for total capacity, basically 10 millimeters times 10 minutes, go to 100 milliliters. Right? So in this case, we know that tap A leak water at a faster rate. So that means we can say let 1 unit be rates of tap B. So that means the capacity of the bucket is equal to 1 unit times 80 minutes. So tap B 80 minutes, because tap B filled up the bucket. So capacity of bucket is 1 unit times 80 minutes is 80 units. Then tap A rate, according to this statement, is 1 unit plus 30 milliliters. So that means the capacity of bucket with the tap A rate, since tap A, to fill up the buckets is 50 minutes. So that means is 50 times bracket 1 unit plus 30. And this will be 50 units plus 150. Since the capacity of bucket is the same, that means 50 units plus, or in essence 80 units equal to 50 units plus 150. So 80 units minus 50 units, this will give us 30 units equal to 150. So 1 unit equal to 150 divided by 30, this will give us 5 milliliters. And what is 1 unit? Is the rate of tap B. So capacity of bucket according to tap B rates is 80 units, which is essentially 80 times 5 is, sorry, there was one mistake, which is 50 times 30 is not 150, it's about 1500. So that means 1 unit is not 5 ml, but 50 ml. So that means the capacity of the bucket is 80 times 50, and this will be 4000 milliliters, or in this case 4 liters. So the answer to this question is 4 liters. Question 9. Part A. Jeremy was given the same amount of money each month. In January, he spent $30 and saved the rest. In February, he spent 30% less than in January and saved the remaining $27. How much did Jeremy spend in February? So from the question, in January, he spent $30. So that means 100% spent equal to $30. Then February, he spent 30% less, which means percentage spent in February is equal to 100 minus 30 equal to 70%. Therefore, 70% spent, which is February, is equal to 30 divided by 100 times 70, and this will be $21. So for part B, question 9 part B, what was the percentage increase in amount Jeremy saved in February? So now we know that the spent is $21 and he saved in February is $27. So total in terms of February is equal to 21 plus 27. This will be $48. Since total is the same for each month, that means for January, total is $48. And then January spent is $30. So January saved is basically 48 minus 30. This will give us $18. So difference saved in January and February is equal to 27 minus 18. This will give us $9. So percentage increase in February is basically difference saved in February and January divided by saved in January and then times 100%. So in this case, the difference save is 9. January save is 18 times 100%, not 19, 18. And this will give us 50% increase. Right, there you go. So that's the answer. The bar graph shows the number of television sets some families have in their home. The number of families with 2 television sets is missing in the graph. 1/3 of the families have 2 television sets in their home. How many families have only 2 television sets in their home? So first thing first, when you see a graph, we need to calculate the number of gaps before the first number. So we have 1, 2, 3, 4, and 5. So we have 5 gaps, equal to 20. So 1 gap is equal to 20 divided by 5. This will be 4. So now it says here 1/3 of the families have television sets in their home. So that means the remaining is basically 1 minus 1/3. This will be 2 out of 3. So let's calculate the number of televisions for each. So we have 1, 2, 3. So this will be 12 for 0. Then for 1, we have 40. Then for 3, we have 20 plus 4. 20 plus 2 times 4. So 3 TV sets is, in this case, 28. So that means the remaining would then be equal to 12 plus 40 plus 28. And this will be equal to 80. Since remaining in terms of fractions is 2/3. So 2/3 of people is equal to 80, or families in this case. So 1/3 of families, which are 2 TV sets, is 80 divided by 2. This will give us 40. There you go. So the answer is 40. So question 10 part B. What is the average number of television sets each family have in their home? Since we know all of the numbers, then we will just add. So average number of TV sets is equal to total TV sets divided by total families. So let's calculate the total families. In this case is everything over here, 80 plus 40, which is 120. So total TV sets. So we don't need to care about the 0. We can, but not really that important. You can just put 0 times 12. Then plus for the 1. Remember, for the 1 TV set, we have 40. So 1 times 40 plus for the 2 TV sets. 2 TV sets, we have 40 as well. So 2 times 40 plus, then with the 3 TV sets. 3 TV sets is 3 times 28 families. Okay, and if you were to calculate everything, it will be 204. So now we know the total TV sets and the total families. Then we have the average, which is 204 divided by total families is 120. And this will be equal to 1.7. So that's the average number of TV sets. Question 11, part A. The figure below is made up of 2 quarter circles and a rectangle overlapping one another. The length of the rectangle is 14 centimeters. Take pi equal to 3.14. Find the missing length k. So it's over here. I think this is pretty straightforward. So 4 plus k is equal to 14. That means k is equal to 14 minus 4. This will be 10 centimeters. Okay. So for part B, find question 11 part B, find the area of the shaded figure. Okay, so in order for us to get the shaded area, first thing first is we need to get this unshaded area A. So how do we get this unshaded area A? So the rectangle that you see over here, let me mark it in red like this. And then we minus with the orange and we'll get the unshaded area A. So once we get the unshaded area A, then the next thing is we can just have the whole of this quarter circle, which you see over here, minus the unshaded area A, and you will get the shaded area. So to get shaded area, we basically need to have the quarter circle minus unshaded area A. And to get unshaded area A, we need to get the rectangle minus the, I call this the big quarter circle just now, and we minus the small quarter circle. All right. So with that said, let's do the unshaded area first. For the rectangle, since we know k from the previous question, the rectangle is basically 10 times 14. This will be equal to 140. Then we want the small quarter circle, which is 1 quarter times. So what is the radius over here? So the small quarter circle radius basically 10 centimeters. Okay. So small quarter circle area is to 1 quarter times pi times radius times radius. So we know 1 quarter times 3.14 times 10, and this will be equal to 78.5 centimeters square. So once we know the small quarter circle area, so the unshaded area A would then be equal to the rectangle, which is 140, minus the small quarter circle, 78.5, and this will be equal to 61.5 centimeters square. Okay, now after that, once we find the shaded area A, the next thing is we get the big quarter circle minus the shaded area A. I'm just blocking the other part. So shaded area would then be big quarter circle minus unshaded area. So the big quarter circle radius is 14 centimeters. So this is the big one. So that means the big quarter circle is 1 quarter times pi times radius. And this will give us 153.86 centimeters square. So the shaded area would then be the big quarter circle, which is 153.86 minus the unshaded area A, 61.5, and this would be 92.36 centimeters square. Question 12, part A. Joanna has 4 identical large cubes and small identical small cubes. She packs all the cubes tightly in a rectangular container such that the cubes of the same size are stacked on top of each other. The box was filled to the brim exactly. The figure below shows the first layer of cubes packed in the box. How many small cubes does Joanna have? Alright, so if you were to look on this at the top view, you see this. So the 2 large ones that are both in L, and we have the small ones, right? So the thing is, can we figure out an equation over here? This requires us to use simultaneous equation. If I were to just make this disappear a bit, you can see that the 2 large ones over here is equal to 3 small ones over here. So that means the large one, 2 large is equal to 3 small. And since we know from the question 4 identical large cubes. So that means we have an additional 2 more over here. So it will look something like this, right? We have 2 large, and then we add, so 1 row of large is 2 large, and then if we have 4 large, that means we don't need 4 large actually, because we already calculated. So 2 rows of the large cube is equal to 4 cubes. So 4 large cubes is 2 rows of large cubes. So which means that 2 rows of large cubes is equal to 2L. So 2L is equal to 3S. So that means 3S is 3 rows of small cubes. And 1 row of small cube over here, if you were to count, is 9 cubes. So that means 3 row of small cubes is equal to 3 times 9, and this will give us 27 cubes. Okay, there you go. So for part B, question 12 part B, the length of small cube is 4 centimeters. So that means this length over here is 4, which also means that this is 4, this is 4, and this is 4. So we want to find the volume of the rectangular container. So two large lengths, two large cube sides is equal to 4 times 3. This will be 12 centimeters. So one large cube side will then be 12 divided by 2. This will give us 6 centimeters. So in total, cubes is equal to 4 large cubes plus 27 small cubes. Or total or volume or container volume cubes is this. Okay, so from here we can just get one large cube volume, then be equal to side times side times side, and this will be 6 times 6 times 6, 216. Then we want one small cube volume, which will be 4 times 4 times 4, which will be 64. So now we know the volume for the large and small cubes, and we just multiply. So 4 large cubes equal to 4 times 16 plus 27 times 64. And this will be equal to 2,592 centimeter cube. All right, question 13A or part A. The figure below shows a right-angled triangle ABC drawn on the square grid. Using a protractor, measure ACB. So to usually get the angle from a triangle, what you need to do is to draw a straight line, something like this, so that when you put your protractor over here, it nicely sits on this point over here. Make sure the line is parallel to the base of the triangle, and you can see over here. Okay, so generally if the line is closer to the, so it's 30 and then it goes to 4, it's generally just 34 degrees in this case. So now let's move to part B. So part B over here, draw a parallelogram on the square grid. This parallelogram has the perimeter of triangle ABC. So triangle ABC over here, we want to get the perimeter. How do we get the perimeter? Essentially, you just measure the length and breadth, as what you see over here. So according to the number of squares, so if 1, 2, 3, 4, 5, 6. So you have 6 squares. And then over here, we have 1, 2, 3, 4. We have 4 squares. And then lastly, what's AC? So AC will be a bit different. We need to get the point from A to C using vertical and horizontal arrows, something like this. So it's similar to what we have measured for our base and height, but now it's measured in terms of like the direction as what you see over here. So 6 and 4 as well. So in this case, we want to draw the same parameter as triangle ABC with a parallelogram. So we actually can just split this. So we have 4 and 6. That means we can actually get the line to be 5. So I will say straight lines total parameter is equal to 6 plus 4 equal to 10 cubes length from ABC or triangle ABC. So that means straight lines total parameter for parallelogram WXYZ is equal to 10 cubes length or 2 straight lines. So one straight line for parallelogram WXYZ is 10 divided by 2. It will be 5 cubes length. So generally that means it's 1, 2, 3, 4, and 5. Something like this. So we can just have some sort of this. Then 6 and 4 for diagonal lines. For diagonal line from triangle ABC, it is 6 horizontal plus 4 vertical in this case. So that means total diagonal line for parallelogram WYXYZ will be 6 horizontal plus 4 vertical. So which means if you want to have one diagonal line, because it's the two diagonal line for sim parameter, right? That means it is 3 and this is 2. So we divide each into 2. So if you were to calculate, that's what we set over here. This will then be 2, 1, 2, like this, or we can move over here. 2 vertical and then 3 horizontal. Gotta put here 2 and then 3 horizontal and move it inwards. So 1, 2, and 3. Something like this. Therefore, this itself is our parallelogram. Question 14, part A. In the figure below, ABCD is a square, BCF is an equilateral triangle, and ADEF is a trapezium. AGF is a straight line, and angle DEF is equal to 102 degrees. Find angle AGC. So angle AGC will look something like this. So how do we get angle AGC? Just using words, right? So angle AGC, it's basically 180 because this is a straight line like this. So 180 minus angle BGA, which is this angle over here. So for angle BGA, essentially, we need to, it's part of this triangle. So BGA is part of this triangle, which means 180 minus. And we also know that this is a right angle triangle because this triangle is inside the square. And lastly, we need to find this angle, BAG. So then how do we get angle BAG? To get angle BAG, it's part of which triangle? FBA. So I'm going to highlight like this. So FBA is this triangle in green. So what is this triangle FBA? What type of triangle is FBA over here? So triangle FBA, since BA is equal to BC as equal sides of triangle, and BC is equal to BF as equal sides of equilateral triangle. That means BC is equal to, BF is equal to BC is equal to BA. Okay? BC, BA, and then BF. So which means that, or BF is equal to BA. So therefore, triangle BFA is an isosceles triangle. So that means for the angle BAG in green, basically 180 minus this other angle. I'm gonna highlight this in orange like this, minus FBA, so angle FBA, and then we divide it by 2 since it's an isosceles triangle. Okay, how do we get angle FBA? Angle FBA, it's basically, if you were to see it here, this angle is 90, and since angle FBC, so FBC over here is part of the equilateral triangle, which means this purple part over here is 60 degrees. So that means angle FBA, it's basically 60 plus 90 equal to 150 degrees. So from here, we can get angle BAG, which is the green color angle. So 180 minus 150, which is FBA, divided by 2. This will give us 15 degrees. And since we know this is 15 degrees, we can find the blue angle, which is BGA. So I forgot we also need to minus 90 over here. So angle BGA in blue, it's equal to 180 minus BAG minus 90. So now we know BAG, that means this is 15, and the answer to this is 75 degrees. And since we know the angle BAG is 75 degrees, then that means the angle that we're looking for, angle AGC, it's basically 180 minus BGA in blue, which is essentially 180 minus 35, and this will give us 105 degrees. There you go. So that's the answer. So question 14, part B, we need to find angle CFE, which is this angle over here. So angle CFE, how do we get this angle? We basically need to find this bigger angle minus this smaller angle. So let's write it down. So angle CFE in red is equal to angle EFG minus, is in green, minus CFG, is in blue. So to get the green color one, it's pretty straightforward since ADEF is a trapezium. So I'm going to highlight in green. So angle CFG is basically 180 minus 102. This will give us 78 degrees, okay? Because adjacent angles in trapezium totals 180. Pretty straightforward. So now we know CFG is 78 degrees. The next thing is we need to find this blue color angle. So for this blue color angle, we know that ABCF is an equilateral triangle. So which means we need to find this other angle, BFG, and then minus 60. So angle CFG in blue is equal to 60 minus the purple one, BFG. So in the earlier question, we actually were able to get BAG, which is also the same as BFG. So to just recap, BFG is part of the triangle BFA or FBA. And since BA is equal to BC, because they are sides of the square, and BC is equal to BF because they are equilateral triangle. Therefore, BC is equal to BF. Then from there, the BFG is in purple, basically 180 minus FBA. So FBA is over here. So FBA has a right angle triangle, and we know that this over here is 60 degrees. So that means if we add them, it's 150, and from there we can get the side BFG purple is 15 degrees. There you go. Now with this 15 degrees, we can actually get PFG, which is the blue color. Since this is also 60, so you see over here, that means it's 60 minus 15. This will be 45 degrees. Since we know this is 45, and we know that this whole trapezium itself and this angle, this green angle that we calculated earlier is 78 degrees, then essentially 78 minus 45, and this will give us 33 degrees over here. Okay, there you go. So the answer is 33. All right. Question 15, part A. A fruit stall has a total of 1,425 apples and pears. After selling 40% of the apples and 225 pears in the morning, the ratio of the number of apples left to the number of pears left became 3:1. How many pears were left? Right. To start off, we want to know what's the percentage of apples. So apples at first is 100% and apples sold is 40%. So that leaves us with apples left, which is 100 minus 40, which is 60% left. From the question, it says the ratio of number of apples left to the number of pears left became 3:1. So that means apples left units will be 3 units. It also means that 60% is 3 units. And then 100% of the apples at first in terms of units would then be equal to 3 divided by 60 times 100, which is 5 units. So also from the question, it says pears left is 1 unit and pears sold is 225 in the morning. So that means pears at first would then be equal to 1 unit plus 2 to 5. We also know that the total at first is 1,425 apples and pears. We also know that total at first will then be equal to apples at first plus pears at first. Do we know this? Yes, we do. Apples at first, if you were to scroll here, it is 5 units. Pears at first is 1 unit plus 2 to 5. Means if we were to add these two equations together, this will give us 6 units plus 2 to 5. Since we know that the total at first is 6 units plus 2 to 5 and total at first is 1,425, that means we can actually calculate 6 units, which will then be equal to 1,200. Since pears left is 1 unit, so we will have 1,200 divided by 6, and this will give us 200 pears. So question 15, part B. The fruit stall sold more apples in the afternoon, such that the ratio of numbers of apples left to the number of pears left became 3:2. How many apples did the fruit stall sell in the afternoon? So I created a table. Apples, pears. So in the morning, we had 3:1, so 3 and 1. And then we know from the question it says it sold more apples in the afternoon. So we minus some apples, but we don't know how many. And then we are left with apples to pears, which is 3:2. So this is what we call the constant part, because pears did not change at all. So that means pears are the same or constant. So we need to make them the same number using lowest common multiple. So from here, we can just times 2 this. This will become 2. Since we times 2 this will become 6. So therefore, the morning sold in units is actually just 6 minus 3 equal to 3 units. Not morning sold, afternoon sold. Come 3 units. We see over here. So in the previous question, we were able to get the number of units we have over here. So let me call them parts instead. We don't get confused. So we know that pears left in the morning is equal to 1 unit, which is 200. That means 2 parts will then be equal to 200. So how much we are sold? Basically 3 parts. 6 parts, 3. So therefore, we sold is 3 parts, which is 200 divided times 3, which will be 300 apples. So there you go. So the answer is 300 apples. Question 16, part A. Whaley used 1/4 of her pocket money to buy 3 pens and 7 erasers. The cost of each pen was 3 times the cost of each eraser. Weili bought some more erasers with 5/6 of her remaining pocket money. She spent $36.10 more buying the erasers than the pens. How many erasers could Weili buy with the amount of money for 3 pens? So from the question, the cost of each pen was 3 times the cost of each eraser. Means 1 pen is equal to 3 erasers. So how many erasers could William buy with the amount of money for 3 pens? So that means 3 pens, that be 3 times 3 equal to 9 erasers. Okay, pretty straightforward. So the next part, question 16 part B, he spent $36.10 more buying the erasers than the pens. What was the cost of 1 eraser? So over here, let's use units. Let 1 unit be the cost of 1 eraser. So that means from the statement, we know that 1 pen is 3 units and 1 eraser is 1 unit. So from here, we can then get 1/4 of the money from the question. So Willie used 1/4 of her pocket money to buy 3 pens and 7 erasers. In this case, if we were to calculate it, it will be a total of 16 units. Then from the question itself, Willie bought some more erasers with her remaining pocket money. So that means Willie bought the remaining of her money, which is 3/4. Then she will use the 3/4 of her money, which is basically 3 times 16, because 1/4 is 16 units. 3/4 is 3 times 16, which is 48 units. Then from there, he bought more erasers with 5/6 of the remaining. So more erasers would then be equal to 5/6 of the remaining 48 units. So 5/6 times 48 units, this will be 40 units. Since 1 unit is 1 eraser, then 40 units is basically 40 erasers. So that's how much more erasers he bought. So the total erasers will be the 40 erasers plus 7 that he bought in the question earlier, and the total will be 47 erasers. So therefore, the total eraser cost will just be 47 times 1 unit will be 47 units. So the difference in terms of the cost would then be 47 units of total eraser cost minus the 3 pens that it has, which in this case is total eraser cost minus total pen cost, which is 38 units. We also know that the difference in cost is actually $36.10, which means 38 units is also equal to $36.10. So 1 unit would then be equal to 95 cents, which is also the cost of the eraser. So the answer should be 95 cents. There you go. Question 17, part A. A company offered 100 handphones at 25% discount during a 7-day sale. The line graph shows the number of handphones left unsold at the end of the day. On which day was the most number of handphones sold? So in this case, we can calculate the number of handphones left unsold. But first, we need to always calculate the gaps. So from here, day 1, we have 1 gap, 2 gap, 3 gap, 4 gap. So 4 gaps equal to 20. 1 gap equal to 20 divided by 4. And this will be 5. So to calculate the number of handphones sold, that means handphones sold will be basically previous day unsold minus current day unsold. So for example, day 1 handphone sold is basically previous day is 100, then minus. So day 1 over here, this will be 70. The answer should be 30. So I've calculated all the unsold on different days. So day 1 is 30. Then for day 2, we have 70 minus 60, which is 10. Then we have day 3 is 60 minus 35, which is 25. We have day 4, which is 35 minus 25. We have day 5 is 35 minus 20. Day 6 and day 7 essentially is just 20 minus 10 and 10 minus 5. So out of this, which one has the biggest difference? The biggest or number sold is day 1, which is 30. There you go. So question 17b, what fraction of the number of handphones was sold in the first 4 days of sale? So we can use what we do in question 17 part A, which is to get all the number of handphones sold. So 30 plus 10 plus 25 plus 10. And this will be 75. So fraction of total sold in first 4 days then be 75 out of total 100 will then be 3/4. There you go. And question 17, part C. After the sale, the remaining handphones were sold without discount. The shop collected $32,330 from selling 100 phones. How much was the price of each handphones before the discount. So this 7 unsold is equal to 5. So that means total sold is basically 100 minus 5 equal to 95. So this is total sold during 7-day sale. So if you're not sure what to do next, the easiest way is to get let's 100 units be price of handphone. So the discounted price in units, since we have 25% discount, basically 100 units times bracket 100 minus 25%, okay, and this will be equal to 100 units times 75%, which is 75 units. So that means the total collected in units of 7-day sale will then be equal to 95, because we have the 95 here, right? Times 75 units, and this will be equal to 7,125 units. So total collected in terms of units of remaining will then be 5 times 100 units. This will be 500 units. So therefore, total collected will then be equal to 7,125 units plus 500 units. This will then be equal to 7,625 units. We also know that total collected is equal to 32,330. So that means 7,625 units is equal to 32,330. Then we can get 100 units, which is 32,330 divided by 7,625 times 100, which is the price of one phone before discount, and this will be equal to $424. There you go. So that's about it. If you like this video, give it a thumbs up. If you want more of this kind of video, subscribe down below and comment down what other things you want me to show you next. See you in the next one. Bye bye.